You may have noticed during earlier parts of this video series there was some unevenness and actually some grabbing of the carriage as it was moving along the ways, and I finally decided it was time to do something about that. I had planned to do a video on that anyway, and since this particular lathe was exhibiting the exact symptoms for which you might want to do that adjustment, seemed like a great time to dig in and do that. So I did create a new short video series called Adjusting the Saddle Plates, and went through that process and got it fixed, and it's now working real nicely. Unfortunately, while I was doing that, I ran the carriage back and forth without the saddle being tightened down, or the apron, the front part here, and the gear scored up the paint here along the underside of the rack. So that was my fault. I thought at first that maybe that was a factory adjustment error, but in fact it was a user error on my part. So live and learn, I guess. I should know better. But anyway, we're ready to dig back in and wrap up this series on the LMS Model 5100 7x16 Mini Lathe. And I think we'll next tackle the tailstock and see all the features that you have there. So let's go ahead and do that now. The tailstock is this assembly on the right end of the lathe, and it can slide back and forth along the ways, and it can be locked in any particular position by using this locking lever here, and that creates a clamping force which holds it in place. Now on some lathes, instead of a locking lever, they just have a nut that you have to tighten here, but this is a lot more convenient, because if the tailstock happens to be up close to the carriage, for example like this, it can be very difficult sometimes to get access in here with a wrench to loosen and tighten that nut. So this is a real desirable feature when you're comparing lathes. You look at the different, low end versus high end. You'll notice that on the low end lathes they usually have just a nut here, whereas on the high end lathes, I'm speaking just of mini lathes here, the higher end models typically have this locking lever feature. So most of the time the tailstock often is used for drilling, and because of that it has a drill chuck mounted in here. And if you look at a lathe, a lot of times you'll see the drill chuck in there because that's very frequently used. But there are other types of tools and accessories that you can mount in the tailstock, and so the tooling, whatever it happens to be, is held in place by a Morse taper arbor. In this case, this is called a Morse taper number 2. And that's just the size designation for it, but it mounts into the chuck, and then the chuck in turn slides into a matching taper, a female taper, in the tailstock itself. And that taper is actually part of what is called the tailstock ram, and the ram can be extended out from the tailstock by turning the tailstock hand wheel. This is also sometimes called the tailstock spindle, or the ram. And the ram has, it's calibrated in this case in inches. On some lathes I've seen it's calibrated in millimeters, and in some it's calibrated in both units. And on some lathes there's also calibrations on this dial, or on this ring around the tailstock hand wheel, that reads out maybe in 20ths of a millimeter or 10ths of a millimeter, and or in thousandths of an inch or whatever, but this lathe does not have those markings on it. So zooming in on the scale, you may be able to see the inches and fractional inches marked on here. It may be a little bit difficult to see due to the reflections from the lighting, but anyway, they're there, and they're real handy when you're trying to drill to a specific depth or an approximate depth. And if you need to drill to a more accurate depth, you can usually rig up a dial indicator or some other way to more accurately measure that if you need to. When you're ready to use a particular type of tooling, in this case, for example, the drill chuck, the taper first has to be seated into the ram, and the way you do that is just get it started, and then before it's pushed all the way back, you need to just whack it into place, and the force of the two tapers coming together locks it up very tightly. Then if you need to remove the tooling, you simply turn the tailstock hand wheel counterclockwise, and eventually the back end of the arbor will hit a stop point in the back of the tailstock and force the taper loose so that the tooling can be removed. So that's the process for inserting and removing it. Now, when you go to buy a chuck for your mini lathe, and by the way, on this particular one, the chuck and the arbor are not included. They are sold separately, and it's something you really want to get at the same time you get the lathe. It's a very essential piece of tooling. Some mini lathe packages include that, and some do not, so you have to check depending on the vendor you're looking at. But when you do select the arbor, be aware that you need a shorter than normal arbor. A normal Morse taper number 2 arbor is typically about 1 inch or 3/4 of an inch longer than this one, and in that case it's actually a little bit too long, and they actually may have a tang on the end, which is used in some types of machinery to prevent the tooling from twisting in the ram, but that's not needed or used on this type of lathe. But if you have that, it will cause the chuck to stick out farther than you may want from the end of the ram. So this particular arbor that is sold by LittleMachineShop.com is just the right length to match this lathe, and therefore is a good choice if you're going to get one. So we'll go ahead and get that in place, and then I'll demonstrate a drilling operation. On one other minor point here I should make while I'm at it, I like to position the chuck, the angle of the chuck, or the rotational position of the chuck, so that I can easily get access to 2 of these holes for the chuck key. If you turn it like this, 2 of them are hidden in the back here and are harder to get to. And I like to tighten the chuck up with at least 2 of those holes to make sure it's closed tightly and evenly. So I like to put it with one of them pretty much at the 12 o'clock position and the other one here at about the 4 o'clock position, and knock it in place. Now, when you're drilling holes on the lathe, and in a lot of machine work, you typically start or often start by using a center drill. And this is a little specialized drill called a center drill and countersink, or sometimes just called a center drill. But it's a short stubby drill that's used to start the hole, and its purpose is, because it's stiff and doesn't twist or bend much, it ensures, I didn't get that chuck all the way in there. I had the ram too far back when I attempted to seat the chuck, and therefore it didn't lock up. Okay, there we go. But the center drill goes into the chuck and is used to start the hole, to make sure that when you drill with your full-length drill, that it doesn't wander off center and give you a hole that's misplaced, or perhaps even goes off at an angle from where you want it to. So now I need to locate the chuck key and tighten that down. And it's just a standard Jacobs style chuck. And I say Jacobs style because of course Jacobs is a brand name, and made this style of chuck famous many, many years ago. And they're generally referred to as Jacobs chucks, but that is in fact a trademark name. So this one is a Chinese copy of a Jacobs chuck, and it's actually a fairly decent chuck for the price range, and I'm happy with it. So let's go ahead and start our hole and see what happens. When you're drilling on the lathe, the drill bit and typically the chuck have to go over the carriage, and so I like to crank the cross slide all the way out towards the operator so that it's out of the way. You may also have to crank the compound slide back, and it's also handy if you remove the tool post. It gives you better access to see what you're doing and be able to move things around if you need to. But you need to be careful, obviously, that you don't have the carriage up to the chuck so close that the chuck might hit it when it turns on. So it's a good idea to, once you position the carriage, do a test turn of the chuck. Make sure that it's not going to come anywhere close to any part of the carriage or the compound before you power up the lathe. Okay, we've got my tailstock locked down with the locking lever, and we're ready to begin our drilling operation. I have the lead screw turning right now. I'm going to turn that off because I don't need it, and it's going to add some extra noise that I don't want. All right, now with the lead screw off, go ahead and turn up the speed a little bit. and begin our drilling operation. And I like to use some cutting fluid, and I have to grab my cutting fluid bottle. But when you're drilling with the center drill, you only drill in about 2/3 of the way up on the cone-shaped part of it. And let me see if we can zoom in and give you a better look at that. So we're using this cone-shaped tip here on the center drill, and we're just going to come up about to the end of that cone-shaped area there and not beyond for our starter hole. Alright, I tracked down my bottle of cutting fluid here, and I'm just going to put a few drops there. I'm already almost past the point where I need it, but this is a product called Tap Magic Aluminum that I've used for many years, and I've been happy with it, so I continue to use it. But there are other brands that probably are equally as good. So you can try different brands, or just pick a brand and try it, and if you like it, stick with it, which is what I've done. But it's a good idea, particularly when you're drilling aluminum. It helps to prevent the chips from welding to the drill bit, which they're inclined to do on aluminum, and give you a cleaner and smoother hole most of the time. Helps the chips to flow freely out of the hole and off of the drill bit. So now that I've got my pilot hole, I'm going to slide the tailstock back and put in my full-size drill that I want to use to drill the hole. So first I need to take the chuck key and remove the center drill. And I'm going to go into my box of drill bits here and select the drill bit. Since this is just a demonstration, the size of the drill bit isn't particularly critical, not critical at all, but I ended up with a, let's see if I can read it here, looks like a 3/8 inch, good enough. So we'll stick that in there and tighten it down in the chuck. And again, I like to use at least 2 of the holes here, make sure I have it clamped in there evenly. And you have to be careful sometimes, particularly with smaller drill bits. You can get them off center here and wedged up in between 2 of the chuck jaws. And if that happens, your chuck or your drill bit will not be centered on the hole. You can actually snap it off on a bad day. Now this particular drill bit that I selected here is a little bit large for the type of size of stock I have in there, but it's just a demo, so we'll go ahead and try and use it and see how that works out. So it's a 3/8 inch drill bit, and I guess it's 1/2 inch stock in there. And I'll go ahead and put some cutting fluid on the drill bit for the same reasons we've already discussed. Make sure my tailstock's locked down. Now, if you have never done drilling or seen drilling done on a lathe before, one of the things that may surprise you is that this is one of the few times in a machining operation where the drill bit actually is stationary and the work turns. You know, in almost every other drilling situation I can think of, I guess every other drilling situation, it's the work is stationary and the drill bit turns. But that's the way it's done on a lathe, and one nice advantage of that is it has the tendency to cause the drill bit to stay centered in the work. I can't explain the reasons for that, but it seems to be a fact. And because of that, you can often get a very, very concentric hole, much more so than you could, for example, if you tried to do this on a milling machine or on a drill press. While we're on the subject of drilling, it's a good time to talk about the length of the lathe, because drilling is probably the situation where the length can be most important. And this particular lathe is referred to as a 7x16, and the 16 part of that means that it's nominally 16 inches from the spindle to the tailstock. Now that's without the 2 chucks in place. But if you actually measure on this lathe, if you measure from the front of the chuck out here to the front of the tailstock chuck, there's really only 12 inches in there. And that's your actual working distance for a drilling operation. So if you have a workpiece that's fairly long and maybe extends out from the chuck by 4 to 6 inches, I have a 1/2 inch drill bit mounted in here now. And you can see there's not a lot of excess room here. So if you want to drill into the end of that workpiece, probably the longest workpiece you can do that with is about 7 inches, it looks like. So that's something to keep in mind. Now, you probably are aware, if you're thinking about buying a lathe, that they come in several different lengths. The 7x16 is the longest of the mini lathes, but there's also a 7x14, and I've marked here, this is the 16-inch mark, and I've marked 14 and 12. So if you had a 7x14-inch lathe, you've got that much less room, and you can see the gap here, of course, is reduced. And then if you go down to a 7x12, you lose another 2 inches. And then if you went down to a 7x10, you would lose another 2 inches. And you can see now we're getting down to the point with a 1/2-inch drill bit. There's almost no room between the tip of the drill bit and the jaws of the chuck. But in fact, the lathes that are advertised as 7x10 are actually only 7x8. And I won't go into the reasons for that, but you can, but just be aware of that. If you're looking at a 7x10 lathe, it really is a 7x8. And in fact, to my knowledge, there is no mini lathe that is a true 7x10. So if you had a 7x10, or we'll call it a 7x8, you can see that the 1/2-inch drill bit doesn't fit here at all. Now, I started out with a 7x10, and it was a good little lathe. I liked many things about it, but I soon got very frustrated by this exact problem, that in a lot of drilling operations, there just isn't enough room for the drill bit. Now, one way you can work around that to a certain extent is there's a type of drill bits. These are typically called jobber drill bits, and these are the type you would find if you just went down to the hardware store and bought a set of drill bits. But there are some specialized drill bits called screw machine drills, and these you typically will only find at an industrial machine tool supply house like Enco or MSC or someplace like that. But they come in the same diameters in sets of 29, from a 1/16 inch up to a 1/2 inch by 64th, just like your jobber size drill bits, but they're much shorter. So if we take the 1/2 inch screw machine drill and compare it with a 1/2 inch jobber drill, you can see that it's probably about 2 inches shorter. So on a short lathe, particularly on the 7x10, aka 7x8, having a shorter drill bit can be a real advantage because it gives you that extra clearance. So now when we set the tailstock here at the 8-inch mark, we still have a little working room. But that's just something to keep in mind when you're selecting your lathe. The longer bed that you have, the better off you are. Now, if you know in advance that you're going to only be working with very small parts, maybe you're working on parts for HO trains or little model ships or something, and you're not going to be making anything longer than, say, 2 or 3 inches at the most, then the 7x10 may be all that you need. But if you plan to do work that may be 4, 6, or 8 inches long, or even longer, then you definitely want to be thinking about one of the longer versions of the 7X lathe. And it may be that even the 7x16 isn't big enough for your needs, and you really don't want to buy a lathe and then find out that it's too small to do what you like to do.